Hey subscriber, we are going to be looking at question 22 on density. Right, let's get started. So a squash ball is made of rubber in the shape of a sphere. The mass is given to us, which is good. The diameter of the ball is labeled. The thickness of the rubber is given. Assuming the mass of the air inside, so the white bit, is negligible, calculate the density. So density is what we're going to work out. First thing we do, like I mentioned in all these videos, is check the units match. So you've got millimeters, 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 all of that is fine, grams. However, the answer, very annoyingly, is in centimeters cubed. That might be a good thing. It might mean it's easier to do it. What this essentially means is it's going to be easier for us to convert it at the beginning. So 40 millimeters, we know that to convert from millimeters to centimeters, 1 centimeter is 10 millimeters. So 40 centimeters is going to be 4 centimeters. 4 millimeters, we're going to divide by 10, so it's going to be 0.4. And then we've got, what else have we got? Now, let's label this. So we know the distance from the center to the circumference is 20. But then we know, because of the 4 millimeter thickness, is 20 minus 4 gives you 16. So that's this bit here. So we're going to, what we'll do here is essentially we need the mass, or no, the volume of the grey bit. So if we work out the volume of the full ball, take away the white bit, we're going to be left with the grey bit. So that's what we're going to do. So volume of big sphere equals 4/3 pi r cubed. It's a formula you should know. Is equal to 4/3 pi. Now the radius for the large one is 20, so pi times 20 cubed. We'll work that out in a second. And the volume of small sphere equals 4/3 pi r cubed again, so 4/3 pi times, actually we should use centimeters, so that 20 should actually be a 2. I'm going to change that to a 2. I'm not going to start this question from scratch again. And the radius of the other one should be 1.6, because if you have 16 millimeters, then we can say that that will be 1.6 centimeters. So this now goes in the calculator. So fraction 4/3 times 4/3 times pi times 2 cubed, which is 8. So that's going to give you 32/3 pi. Now we're dealing with centimeters here because we've switched everything to centimeters. So it's going to be centimeters cubed. So that's the volume of the big sphere. We're going to now work out the volume of the white sphere, which is a small one. So that's going to be 1.6 cubed. I'm just going to press the back key here and edit this to 1.6 cubed. So that now comes out to be 17.15 7 centimeters cubed. Now I'm not going to round this on the calculator. I want to take away the 17 from 32/3 pi. So I'm going to press AC, fraction 32/3 pi, and then take away answer. Did not mean to do that. So let me start that again. Let's just go back and put it here. Okay, so we're doing 32/3 pi, take away this bit. So fraction, did not mean to do that either. Okay. There we go. I put it back in the calculator and we've got our answer here. So 16.35. So we're going to say this is the large sphere, B is a small sphere, and what we've done is A take away B. That gives us the grey bit, so that's going to equal 16.35303. Now you might feel like I'm copying too many digits, but it's important. We don't want to round too much because we will lose accuracy. 696. So we now have the volume of, I'm going to just call it grey because it's the grey bit. Now, in order to work out the density, we're going to do density equals mass over volume. The mass is given to us in the question, 24, over the volume, which is the 16.35. I'm going to put dot, dot, dot because we're not rounding it. On a calculator, we're just going to do 24 divided by answer, which is the previous answer. So I'm going to get 1.4676. Now, this doesn't really specify how to round it, so we're going to round it sensibly. Now, I would say just do a wavy line here and say that's basically 1.447, and it just put to 2 decimal places. You might decide to do it to significant figures depending on what feels okay, but normally these questions do tell you how they want to get your answer to be presented. Hope that was useful. Remember to smash the like button.